Hey everyone, welcome back to this channel. This quick video I'm going to show you how the signal generator in FieldFox looks like in the spectrum analyzer mode. As we know that there's options to transmit a CW signal from port 1 of FieldFox in spectrum analyzer mode. First of all, we have to make sure that we are in spectrum analyzer mode. As you can see here, we are currently in spectrum analyzer mode. Then we go to measure. Then we go to source, and this is where all the setup is. To recap, there are a few options in generating the source. So we can look into this source tracking. So we have sweep. Click this sweep means that it's sweep frequency from start and stop of the setup in the FieldFox. Or we can transmit at the center frequency of your setup. If you choose the center frequency, it will always stay in the middle of the screen, regardless of what your setup is. So you can start from 1 gig to 3 gig, your center frequency will be 2 gig. If you start from 3 gig to 5 gig, your center frequency will change to 4 gig. It's sort of like coupling. When you change the start and stop frequency, it's always stay in the middle. But right now we want to use the port 1 to transmit a different type of frequency, so we select off, and this is where you set the center frequency, and this is the power, and this is the on-off button. Let's look at the physical setup. So this is how the hardware setup looks like. As you can see, port 1 is connected to a splitter, and this cable connecting to the channel 1 of the EXR to show you the time domain, and the other part of the splitter is connected back to port 2 of the FieldFox. So we can have both screens shown together on the same recording so that you can see what's going on when I turn on or off the source from FieldFox. So let's start with 100 meg. So you can see there's a lot of harmonics. It's not really clean signal, means that it's not a sine wave type of signal that is transmitting from port 1. So this is very crucial information, especially when you plan to use port 1 to drive a mixer. And if you're using it at low frequency, and chances are you can't drive the mixer correctly because of all these harmonics that happens. It's not a design flaw, it's by design. So you can turn off or on. So as you can see, this is how it looks like in the time domain. I'll change this one. So as you can see, the signal is quite close to square wave because there's a lot of harmonics involved when coming out from port 1. So let's change to 1 gig. You can see that it changes a bit, but it's still very much like a square wave, not so much of a sine wave. So as the frequency goes up, let's say we do a 2 gig. So the signal smoothen, but you still see some harmonics component in that signal. Because this scope has a limit of 8 GHz bandwidth, I can't really push it to more than half of Nyquist. If I show you a 3 GHz or 5 GHz signal, it doesn't really represent the real deal because the harmonics has been clipped off and the signal looks like it is really close to a sine wave, but in actual fact it's not really because you still see the harmonics component here. And the summary is that if you really want to use FieldFox port 1 in spectrum analyzer mode to drive your mixer or to use it as a clean source, you might want to rethink that because as you can see here, there are plenty of harmonics coming out from that source. Again, this is by design and there's nothing much you can do about it unless you put a good filter to get the source cleaner. So I hope this helped. Thanks for watching.